Hi guys, today we're going to learn about absolute value in equations and inequalities. So in this section I will go over the definition and properties of absolute value equations and inequalities. I will solve, interpret, geometrically, and graph absolute value inequalities. I will put answers in both inequality notation and interval notation. And finally I will solve an absolute value problem with two cases. So let's get started. So let's go over the definition of absolute value in equations and inequalities. So the definition of an absolute value is the absolute value of a real number x, denoted by absolute value x is the distance from x to the origin. So in the algebraic version, you have an absolute value. It's when x is greater than or equal to 0, or when you have negative x is when x is less than 0. So an example would be absolute value of negative 6 is positive 6, and the absolute value of 5 is just positive 5. But let's show it on a number line. So let's say you wanted to find the absolute value of negative 6. It's pretty much how many units from the origin, right? It's pretty much how many units from the origin. So from negative 6, how many units is it from the origin of 0? It's positive 6, right? So it's 6 units. The same thing with 5. Here you start with 5. How many units is it from the origin? You move 5 units, right? And it's positive 5 because it's just 5 units. So that's the definition of what an absolute value is. It's pretty much how many units from the origin. Now there's like special rules for absolute values. So let's go over some of these rules. So the properties of equation and inequalities involving absolute value for when p is greater than 0. So the first rule is absolute value of x is equals to p is equivalent to x equals p or x equals negative p. So it just means you have two answers. On a number line you have, so here's positive p and negative p, right? Okay, so that's only when you have equal. So when you have an absolute value, just remember when you have an absolute value, just a regular absolute value, you're going to get a positive number and a negative number. That's what rule 1 says. Rule 2 says the absolute value of less than p is equivalent to negative p less than x is less than p. So what they're saying is when you have an absolute value, doesn't like absolute value 5, and you have that less than, you're going to have an and problem. It's going to look something like this, an and. Remember, you know what and problems of an inequality, it's going to connect. So that's like equivalent so this is in notation form. So it's going to be x is greater than negative p and less than p, right? So that was rule 2. Rule 3, when you have an absolute value greater than, when you have a greater sign, it's going to be an or problem. So it's going to go like this, an or. So it's really saying x is less than negative p or x is greater than p. So know the difference. Less than, it's an and. Greater than, it's an or. And then, yeah, that's the 3 rules. So all you have to remember, the first one is if you're just regular with x, regular absolute value, it's just 2 answers, positive p and negative p. If it's less than, it's going to be an and if it's greater than, it's going to be an or. Okay, so I think we could actually start doing problems. Wait, I think I gotta, yeah, I think, oh wait, did I go over, let's go, before that, before we do any more problems, let's go over the distance of the number line. So the distance of a number line, the distance between A and B is absolute value of A minus B equals absolute value of B minus A. So you just got to determine your A and your B. So this is the distance of a number line. So this equals to this, and then so let's say you got 2 points, D, A, and B, right? It's going to be the absolute value of B minus A. And I will show, here's an example. Find the distance between the points A and B with coordinates A and B. So let's say you're given A equals 4 and B equals 4. So you're going to use this rule, right? The first one, this rule right here. So you know your A and your B, so you just do the absolute, bring down the absolute value and put the B in front. So that's going to be B minus A. So we know our B is 9 and our A is 4. You get the absolute value of 5. So what they're saying on the number line is here's A, which is 4, and here's B is 9. The distance of that is 5. So that's just the distance rule. So you know the distance rule, you know some of the absolute value of inequality rules. So now we can actually do some problems. Let's see. That was that one. Okay, let's start with the first problem. So let's say it says simplify and write without absolute value signs. So you have the absolute value of square root of 5 minus 5. So we're going to go back to this rule, right? We're going to use this rule. The absolute value, the distance rule A minus B is equivalent to absolute value of B minus A. So let's look at this. What is our A? Our A is square root of 5, right? Yeah, our A is square root of 5, and our B, now our B is not negative 5, right? Wait, our B is actually negative 5. No, our B is not negative 5. This is actually negative B. Negative B is negative 5. So our B is just positive 5, right? This is it's in this form. This thing is in this form. It's A minus B, which is minus. So our B is just regular 5, not to be confused with negative 5. So now we got to put it in this form. So we know our B, so it's going to be absolute value B, which is 5, and then minus absolute value A, which is square root of 5. So that, when you simplify that, you're just going to, what is the absolute value of this? It's just 5 minus square root of 5. That is your final answer. Let's do a distance problem. Okay, so let's say you find the distance between points A and B with the coordinates A and B respectively. So you're going to use a distance rule. So we're going to use this rule. So we have A equals 5 and B equals negative 7. So let's see, we're going to use this rule, D of A, B, the distance rule, is equal to absolute value of B minus A. So our B is negative 7, and our A is 5. Let's just put it into that equation. So absolute value of negative 7 minus 5, absolute value of that. And then the absolute value of that is negative 12. Absolute value of negative 7 minus 5 is absolute value of negative 12. And we know the absolute value of negative 12 is positive 12. So that's your final answer. And on a number line, this is how it would look like on a number line. So here's B, which is -7, right? And here's our A, which is +5. The distance of that from B to A is +12. Good. Okay, let's do... Okay, so the direction says write each of the statements as an absolute value equation or an inequality. So we are given that Q is no less than 2 units from 1. Q is no less than. So let's read this. Q is no less than 2 units from 1. What does no less mean? No less mean? So no less means is going to have this inequality sign of greater than and equal to. And then it's no less than 2 units from 1. So 2 units from 1 simply means there's a subtraction. So how do I write this in an absolute value inequality? So in absolute value inequality, it's going to be Q minus 1, right? 2 units from 1. So minus, that's how I got my -1. Now is no less than, so it's going to be greater than equal to 2. Okay, so now we can solve this inequality. So we know that since this is a greater sign, it's going to end up looking like an or. So how do you set up your absolute value inequality? We know it's greater, so it's going to look like an or, right? So you have to break it into 2. So let's break this into 2. So you're going to have Q minus 1 greater than equal to 2, or you're going to have Q minus 1. Now you switch the sign, less than equal to, and then you add a negative. Now solve for Q. So I'm going to add 1 here, add 1. Q is greater than equal to 3, or, now let's solve this inequality. So you add 1 both sides. You get Q is less than equal to -2 plus 1 is -1. So you're going to get Q is greater than equal to 3, or Q is less than equal to -1. Now let's put it on a number line. So here, my smallest number goes to the left, so here's -1, and the biggest number goes to the right. Let's see, greater than equal to, so we know it's gonna be an or problem, and we know it's gonna be a bracket, and it's gonna go, for this part, it's gonna go to the right, and here's -1, and we know this is gonna be bracket, and it's gonna go to the left. So that's how this is definitely an or, so it's gonna go like this, or since you can also use dark circle, right? Bracket and dark circle are the same thing, so it could look like this either. So either way is correct. So that was 27. Let's do this one. Okay, so the problem says solve, interpret geometrically, and graph. When applicable, write answers using both inequality notation and interval notation. So we gotta solve for U, and then we have to graph it, and then we gotta put it in notation form. So let's solve. So what is this? So this is a less than equal to. So remember the rule for absolute value. Whenever you have an less than, it's going to connect. It's going to be an and problem. So let's break it into 2 problems. So it's going to be U plus 8 less than equal to 3, and because remember that less than means and, so it's going to connect. So it's going to be u plus 8, flip the sign, is greater than equal, and then put a negative. Now let's solve for u. So we subtract 8 from here. U is less than equal to negative 3 minus 8 is negative 5. And let's solve for u for here. So we're going to subtract 8 from both sides. So you get u is greater than equal to negative 3 minus negative 8 is negative 11. So now let's put it on the number line. So we definitely know it's going to connect because it's an and problem. Okay, so let's connect it. Whoops. Smaller number goes to the left. Here's negative 5. Biggest, whoops, this should be negative 11, not negative 5. The smallest number goes to the left, and the most biggest positive number goes to the right. So here's negative 5. Let's see, we know there's an equal sign. We're going to use bracket. And then less than, and yeah, so it's going to connect like this. Or you can also use dark circle and then connect as well. They're the same thing. So now I got to put this in words because it says geometrically and mathematically. So we got to interpret it in words. So what does this mean in words? What does this absolute value plus 8 less than equal to 3 in words mean? Okay. In words it means u is no more than 3 units from negative 8. So absolute value u plus 8 is less than or equal to 3 means u is no more than, no more means no more than means less than or equal to from negative 8. So that's what it means. Now let's put it in notation form. So how do you write this in notation form? Remember, it's going to be u is less than or equal to negative 5, less than or equal to negative 11, right? So u is less than or equal to negative 5, and then remember this part always flips, so it's like saying u is greater than or equal to negative 11. So that's how you write it, and in notation form it would be from bracket negative 11 to negative 5. Good. So that's how you do this problem. Let's do some more. Oh, so yeah, let's do some more, but where did I put it? So yeah, let's do it right here because it's the same directions, but let's do a different problem. So let me erase this part. And we got to follow the same direction as this problem. So let's say you are given oh, I don't know, absolute value of 3x minus 7 is less than equal to 4. So we got to solve for x, graph it on a number line, and then put it in notation form. So we know this is a less than, so what does that mean? It is definitely an and problem, so it's going to connect. So let's bring our two problems together. Let's set up our two equations. So we have a 3x minus 7 less than equal to 4, and 3x minus 7, you change the sign, which is greater than equal to, and then you add a negative. So let's solve for x. So I'm going to add 7 here. You get 3x is less than equal to 7 plus 4 is 7, 8, 9, 10, 11, divided by 3. So x is less than equal to 11 over 3. Let's solve for this one. So we're going to add 7 to both sides. So we get 3x is greater than equal to 7 minus 4 is 1, 2, 3, 4. That's 2, right? I mean 3, 1, 2, 3, 4. Yeah, it's 3, not 2. Divide everything by 3. So you're going to get x is less than equal to 11, less than equal to 11 over 3, and x is greater than equal to 1. Now let's put it on a number line. So let's put this on a number line. So it connects because it's an and, so connect it. What's my smallest number is 11/3 is actually about 3.66. So our smallest number is 1. So our biggest number is 11/3. Now you can use bracket or dark circle because they're the same thing. And so it connects, kaboom. And you know it connects because one is you're going to move this to the right, and then here you're going to move this to the left. That's how you know it connects. You can also use dark circles. So we would write this as, how do I write this in notation form? It would be 1 less than equal to x less than equal to 11/3, right? So x is less than equal to 11/3, and then this one is this one's always flipped, so it's like saying x is greater than equal to 1. So that our boundaries is from 1 bracket 1 to 11/3 and bracket. Yeah, that's how you do that one. Okay, let's do another one. Same directions, but different problem. So let me erase this part. Okay, so here we go. So let's say you're given absolute value of 4 minus 2t is greater than 6. So let's see here. We have this greater sign. So what does that mean? It's going to be definitely be an OR problem. So let's set up our two equations. So it's going to be 4 minus 2t is greater than 6, or 4 minus 2t is change the sign, which is less than, and then add a negative. Let's solve for t. So I will subtract 4 from both sides. You get negative 2t is greater than 6 minus 4 is what? 6 minus 4 is 2. Good. And then divide everything by negative 2. Now, what happens when you divide or multiply negative? You change the sign, so this is no longer going to be greater, it's going to be less than. And then 2 divided by negative 2 is negative 1. And let's solve for t for this part. So we're going to subtract 4 from both sides. 4 cancels, so you're left with negative 2t less than. So what's negative 6 minus 4 is negative 10. Divide everything by negative 2. Now, it's going to be an or, so it's going to be t is what happens when you divide a negative or positive. Divide a negative or multiply by negative. Change the sign, so this is going to be greater than, and then negative 2 divided by negative 10 divided by negative 2 is positive 5. Good. Now let's just gotta graph it on a number line. So let's graph it on a number line. So let's see, what's my smallest number is negative 1. My biggest number is 5. Let's see, this is going to be an or, so we're not going to use bracket, we're going to use parentheses because there's no equal sign. So parentheses to the right, and over here, parentheses to the left. Or what you can do is use open circle, not dark circle because there's no equal sign. Open circle to the right, and then it looks like this. So either way is correct. Now, what you're saying is t is less than negative 1 or t is greater than 5. And then if you want to put it in boundary form, it's going to be from negative infinity to what? Negative 1, right? And we're going to use a parentheses, not a bracket. And then we're going to do a union from 5, parentheses 5, to positive infinity. And then you're going to use a parentheses. So that's how you solve this problem, this absolute value inequality. Let's see. Let me see. Let's do a few more. Oh yeah, okay, so what about this one? Okay, so let me erase this part. Let's say for this one, I actually just want the solution. I don't actually want to graph it. I just want the solution. Let's do this one. Absolute value of 7m plus 11 equals 3. Now remember the absolute value rules. When you have an equal sign, you're going to get two answers, a positive and a negative. So we're not going to deal with any kind of we don't actually have to graph it. So yeah, we're going to get you're going to get two solutions. So my first problem setup is 7m plus 11 equals 3. And then my other one would be 7m plus 11 equals negative 3. We don't have to change the sign because this is not exactly an inequality. There's an equal sign, so it's not technically an inequality. So let's solve for m. So I get 7m, 3 minus negative 11 is negative 8, divided by 7 from both sides. We get m equals negative 8/7. Good. Now let's solve this one. Let's subtract 11 from both sides. So we get 7m equals negative 3 minus 11 is what? Negative 14. Divide everything by 7. I get m equals negative 2. And then you could actually check it, and I did check it. If you put it into this original equation, they should give you a positive 3. So those are my two solutions. M equals negative 2 and m equals negative 8/7. So this is an equal sign, not an equality, because there's just an equal. So you get two solutions. And I think we have a last one. So this is my last problem involves So the question says, for what values of x does each hold? This is one of those problems where you have an absolute value problem with two cases. But it's not hard. It's just what you have to do is for a two-case absolute value problem, you're gonna have to set it up. So we have absolute value of 3x plus 5 equals 2x equals 6. So I'm going to set up my two problems. This absolute value is just 3x plus 5 equals 2x plus 6. And then our other problem, remember the rule absolute value, you get a positive and a negative x. So the same thing we have to do with that. So we're going to distribute a negative right here. So it's going to be negative, and then I'm going to put parentheses 3x plus 6 equals 2x plus 6. Good. Now let's solve for x. So I'm going to subtract 5 from both sides. So you get 3x equals 2x. 6 minus 5 is positive 1. Subtract that 2x, so you're going to subtract 2x from both sides. You get x equals, this cancels, 1. Over here, let's distribute this negative. So this is going to be negative 3x, negative 6 equals 2x plus 6. What to do? Let's move this 6 to the right. So that negative is going to add 6 to both sides. So you get negative 3x equals 2x, and then 6 plus 6 is 12. Move this 2x to the left, so I'm going to subtract 2x. What happens to the 2x? It cancels. So you're left with negative 5x equals 12. Just move this down a little. So I will divide by negative 5, right? So x equals 12, negative 12 over 5. Wait, did I do this right? 6, 7, 8, 9, 10, 11, 12. Oh, hold on. I made a mistake right here. This should not be a 6, this should be a 5. My mistake. So this should be a negative 5. So you should add a positive 5, not a positive 6. So this should be 11 over negative 5. So one of your other answer is x equals negative 11/5. Now, you see you have two solutions. Just like the last problem, you always got to check, especially in a two problem absolute value problem. So we'll put it back into the first original equation. So let's do, let's try 1. So it's going to be absolute value of 3 times x, which is 1, plus 5, absolute value of that equals 2 times 1 plus 6. Let's see here. So 3 times 1 is 3, so this is 3 plus 5 equals 2 times 1 is 2 plus 6. 5 plus 3 is 8, absolute value of 8. And then 2 plus 6 is 8. So we know the absolute value of 8 is 8 equals 8. So that's true. So we definitely can use x equals 1. Now let's try our other one, our negative 11.5. A negative 11.5 is the same thing as negative 2.2. So let's put it into that original first equation. So it's 3 times negative 2.2 plus 5 equals 2 times negative 2.2 plus 6. Let's see, so the absolute 3 times negative 2.2 is negative 6.6 plus 5 equals 2 times negative 2.2 is 2 times negative 2.2 plus 6 is 1.6. Good. So the absolute value of negative 6.6 plus 5 is negative 1.6. So, you know the absolute value of a negative 1.6 is positive 1.6, and that should equal 1.6. So our two solution is x equals 1 and x equals negative 11/5, or negative 2.2. They're the same thing. So yeah, that's how you solve an absolute value with two cases. Just pretty much break it in two and then distribute a negative. So that wraps it up for this section.